Have you ever looked at something kind of wild and messy, like a wave, and wondered how on earth you could turn it into something simple, like a clean, predictable list of numbers? Well, that's exactly the beautiful piece of physics we're going to unpack today.
So, take a look at this. It's like we're looking at a secret code being translated. Over on the left, you've got this complex, wobbly, oscillating wave. And on the right, a simple, perfectly ordered list of numbers. So the big question is, how do we get from that chaos to what is essentially a cosmic playlist?
Now, to get our heads around this, we're not going to drown in heavy math. No, instead, we're going to use an analogy, and I think you're going to love this one, a cosmic guitar. It's really the perfect way to make this super abstract idea feel, well, real. So yeah, let's just ground ourselves in something we all know, a regular old guitar. You know, think about it. It's got a body, it's got strings, you pluck it, and it makes notes. Every single piece of that instrument is going to help us map out that complex diagram we just saw. And check this out. Here's how it all clicks into place. The guitar's body? That's the entire space of possibilities. A single vibrating string on that guitar? Well, that's our wave. The act of plucking that string? That's our action, our measurement. And those clean, distinct notes you hear? Yep, those are the numbers. This is our roadmap for the whole thing. So let's start with the stage itself, right? The place where all this music happens. In the language of our diagram, this is called the Hilbert Space. Think of the Hilbert Space as the container for everything. It represents every single possible state, every single vibration that our little system can possibly have. For a wave, this is its entire universe. So here's the key idea. The Hilbert Space is just like the guitar's body. The body of a guitar sort of defines all the sounds it could possibly make, its total acoustic potential. In the exact same way, the Hilbert Space defines all the states a wave could possibly be in. It's the arena for our cosmic music.
Okay, we've got our stage. Now we need a player, and we need some action. This is where the wave function and this thing called an operator enter the picture.
See this wiggly line? The one labeled with that Greek letter psi? That's our wave function. And it's not just any wave. It's a very specific state, a particular vibration that's living inside that bigger Hilbert space we just talked about.
And this is where the analogy just snaps right into focus. If the Hilbert space is the whole guitar, then this specific wave function is like one single vibrating string. It's got its own unique shape, its own frequency. It's our performer, all set to go.
But you know, a vibrating string is silent until you do something to it. And that's where this piece comes in, the operator. Now, I know it looks like some intimidating math, but its job is actually super simple.
The operator, it's just plucking the string. That's it. It's a mathematical action that we perform on the wave. In the real world, this is what we call making a measurement or an observation. You're basically asking the wave, hey, what's your deal? What's your energy level?
So let's just put it all together. It's a really simple three-step recipe. Step 1, we start with our wave function. That's our vibrating string. Step 2, we apply the operator, we pluck that string. And step 3, well, what happens when you pluck a guitar string? You get a result. You hear a note. And that brings us to the grand finale of our diagram, the result of our action, the music itself. Or, in the language of physics, it's called the spectrum.
After all that, the space, the wave, the plucking, what do we actually get? What does this cosmic music even sound like? This is what we get. Not random static, not a messy smear of sound. We get a clean, specific, predictable set of values, a list of numbers. These are the only notes that our specific wave and our specific pluck are allowed to produce.
So our first note, kind of like the fundamental tone, is a really precise number, 14.1347. It's not around 14, it's not 14.1, it is exactly that. And the next possible note you can get? 21.0220. Again, incredibly specific. It's like the universe is giving us a clear, unambiguous answer.
This whole list of numbers is what's called the spectrum, and you can just think of them as the harmonics of our cosmic guitar. You know how a real guitar string can only produce a main note and its specific overtones? It's the same idea. This quantum system can only give you these specific energy values when you measure it. Nothing in between is allowed.
So let's look at the whole story one last time, from left to right. We start with a universe of possibilities, the Hilbert space, our guitar body. We pick one specific state within it, the wave function, our string.
We perform an action on it, the operator, our pluck. And what comes out? A discrete, predictable set of outcomes, the spectrum, our playlist.
Okay, so why does any of this matter? Well, because this whole process, it's the absolute heart of quantum mechanics. It's how we take these fuzzy, weird, probabilistic systems and pull out concrete, predictable answers. It's how we understand the energy levels of atoms, how we know what subatomic particles are doing. We're turning nature's mind-bending complexity into numbers we can actually work with.
It really makes you wonder, doesn't it? If this is just one wave and one operator, one string and one pluck, just think of all the others. What other cosmic symphonies, what other invisible playlists are just out there, waiting for us to figure out how to play the right notes?